Hello, my lovely viewers. Welcome again to another episode of Mathematics and I. It is your favorite presenter, Jeff Nino, and today we shall be seeing how we can expand an expression with higher powers. How we can expand expressions with higher powers. Now, imagine in an examination condition, you come across a question like this: x plus y raised to the power of 5. Now, it will be a crazy idea for you to say, because we have power of 5, it means I'm going to write this into 5 places. X plus y, x plus y, x plus y into 5 places. Although it is correct, but you will find it difficult to work with it. So how then can we now solve a problem like this? Now, the way we can solve this problem that is will be much more easier for us is for us to apply Pascal triangle. Now, some students don't understand how Pascal triangle works. Now, I will be bringing this out and showing you how you can draw your Pascal triangle and how you can master it. Now, this is how your Pascal triangle looks like. 1, 1, 1, 1. The 1 plus 1 gives us 2. Then I have 1. I have 1. 1 plus 2 gives us 3. 2 plus 1 gives us 3, and then I have 1. Also 1. 1 plus 3 gives us 4. 3 plus 3 gives us 6. 3 plus 1 gives us 4, and then I also have 1. And then again I have 1. 1 plus 4 gives us 5. 4 plus 6 gives us 10. 6 plus 4 also gives us 10. 4 plus 1 gives us 5, and then I have 1. Now, if you see the shape, you will see that it has the shape of a triangle. And this is why it is referred to as Pascal triangle. Now, the next question is, how can we make use of this Pascal triangle in expanding this problem? First of all what you see here are called the coefficients. Okay, they are all called coefficients. This is what you do when you want to expand this. First of all, you take a look at the exponents here, which is the power. Now, my power here is 5. So I have to count to where I have 5 here. Now, the first one is 0. And this is 1. This is 2. This is 3. This is 4. And this is 5. So it means if we are to expand this, we are going to be using this. Okay, as our coefficients. 1, 5, 10, 10, 5, and 1. Now let's take it up so that I can wipe the board and we can start solving. Now I have 1, I have 5, I have 10, I have 10, I have 5, and then I have 1. So let us wipe this off. Now let's expand. This is how it works. The first thing you need to understand is this. The first begins with the original power of 5, and it ends also with the original power of 5 with the other. So now this is what I will do. Don't forget we have our coefficients here: 1, 5, 10, 10, 5, 1. So this is how we're going to be using it. Now the first coefficient here I have is 1, and then what do I have now? X raised to the power of 5. Now what we're going to be seeing now is this. The powers of x as we proceed in the mass will be reducing, and the power of y will be increasing. Okay, the power of x reduces while the power of y increases. And you should also take note of the sign that we have here. The sign we have here is positive. So what does that mean? It means in the whole of our solving, we shall be using the positive sign. Okay, now it will be another situation if it was negative sign. Now, if it is a negative sign, this is how we're going to be doing it. We will be alternating the sign. At first, we will use minus, and in the next, we use plus. In the other, we use minus, in the next, we use plus, so on and so forth. So let's continue now. So here it comes. After we bring our 1 x raised to the power of 5, we say plus. Now, what's my next coefficient? 5. What will now be here now? X raised to the power of 4, y raised to the power of 1. Now you see, our powers reduce, the power of x reduced from 5 to 4, while the power of y comes into the picture, which is raised to the power of 1. Now next, plus, my next coefficient is 10, Now what becomes my x? X raised to the power 3. And here we have y raised to the power 2. You see the relationship. X is reducing, y is increasing, an inverse relationship. Plus, my next coefficient also is 10. Now here becomes x raised to the power 2, and here becomes y raised to the power 3. And then my next coefficient is 5. Here becomes x raised to the power 1 now, and then what do I have now? Y raised to the power 4. Now my last coefficient is 1. Now at this last point, there is no more x, because x reduced from 1 to 0, and under the power law, in indices, anything raised to the power 0 is 1, so there's no more x. So what do I just have left now? Y raised to the power of 5. Are you with me now? So you see, this is how you can expand an expression like this. So let's finish up. Now 1 times x raised to the power 5 still gives us x raised to the power 5, plus here we have 5x raised to the power 4 and just y, because y raised to the power 1 is just y, no need to put power 1, plus here still remains 10x raised to the power 3 and y raised to the power 2, and here also becomes 10x raised to the power 2 and y raised to the power 3, plus here becomes 5x, because x raised to the power 1 is x, and here we have y raised to the power 4, and lastly we have y raised to the power of 5. So this is the result you will get if we expand x plus y all raised to the power of 5 using the help of Pascal triangle. You see how maths can be so simple and easy if you understand how it really works. So I've come to the end of today's class. Please don't forget to subscribe to our channel and don't forget to share this video so that also others can learn from it. In our next video we meet again. Don't forget to keep watching.